we'll do a quick mic check, and it works. Doesn't happen very often, but it works. I'm excited to talk about mechanisms. Very quick intro. My name is Zach. I'm the Director of Software Engineering at AWS. And today we're going to talk a little bit about how we leverage mechanisms at Amazon. But a quick intro. It might be a bit of a repeat, but I'll quickly reintroduce myself. I've spent about seven and a half years at Amazon so far in AWS in about two parts. Started back at Amazon in 2012. Ran some of our messaging services. You may be familiar with them: SQS, SNS, Amazon MQ. When it works, that's all me. When it's not, probably somebody else. In 2018, decided to pick up my family, go all the way down to Australia, to go work with Atlassian, where I ran many of the products, including Jira Software, Service Management, Bitbucket, Status Page, and so on, which also led me to Linktree as a CTO. And then last year, I decided to come back to North America and come back to AWS because of the things I love about AWS, which we're going to talk a little bit about today. So with that, let's dive right in. So what the heck are mechanisms? Well, we're going to get to that in a second. But before we get there, imagine that you as an engineering leader, you as a product manager, you as an engineer, could run a team where you're not constantly firefighting, right? So imagine that you plan your sprint on a Monday, and you run a 2-week sprint, and you actually get to finish your sprint. It's not a dream, right? We can make it happen. So let's talk a little bit about how we make that happen. And why is that important? Why is it really important for us to stop firefighting and have some predictability in the way we operate? Well, largely, it's so our teams can avoid surprises, right? And if there is one thing engineers don't like, it's surprises. And I promise this is, well, I can't promise. I think this is the last cat picture I have. It's also showing my age at this point, because why was the internet built? Well, to deliver cat pictures, right? So, but I'll stop with the cat pictures. So, as I was preparing for the presentation, one of the things I read was every presentation must have a story. So why get off the beaten path? So let me share my story here. So let's go back to 2018. I just joined Atlassian, and Atlassian was going through a massive transformation, taking the product from data centers, where Atlassian was born, to taking the same product, making it multi-tenanted, re-architecting major pieces of the platform, and running it on AWS. And things are going really, really well. Well, this created some more opportunities for us. And that opportunity was, hey, if we wanted to move faster, I think it was time to re-architect some of our systems. So just before I had joined, the engineering leaders and product managers took on a re-platformization project, right? So if you're getting shivers and you're going, oh my God, not this story again, I know, I lived it too, right? So here's how the story unfolded. We had layers and layers and layers of systems and frameworks built into Jira. That included native JavaScript, JSP, Angular, whole bunch of JavaScript, and what the engineering team wanted to do was replace some of that with React, right? A slight tangent, in the time that I've just shared this story, there's probably another 5 new JavaScript frameworks that were just developed, right? So, but I'll digress. So we wanted to re-architect this, and we spent a couple of years, a couple of quarters, not years, a couple of quarters, really taking a hard look and saying, hey, these are the experiences that we're going to re-architect. And here's what happened. We did an absolutely amazing job. We have some of the best engineers in the world. They wrote some of the best code you can possibly imagine, and we shipped it. And as we started to get these experiences out to production, we had these polarizing feedback. Some customers loved it. They loved the new look and feel. They loved how snappy it was. And on the other end of the spectrum, customers were saying, holy smokes, what have you done? My page isn't loading. My dropdown isn't loading anymore. So what did the team do? We started to take a look at some of that feedback. We started getting into a firefight mode. And as that feedback came in, we started fixing it, right? Well, what else do you do? That's a pretty normal response for any engineering leader, any product leader that's in the room. You're probably sitting there going, okay, what's next? Is this all you're going to talk about? No. So we were in this mode, and we kept shipping really great things. And as we fixed them, we high-fived, and we felt that, hey, every new platform, every new system has these sharp edges. So will this. But the problems kept coming, right? What ended up happening was, for months and months and months, the customer escalations were coming in, and the teams were constantly firefighting. So we were bouncing back between customer escalations and firefighting constantly. Well, our engineers didn't love it. Our managers didn't love it. Our customers, the most important folks that we were working for, they did not like what was happening. So what that led us to is a recognition that, something is broken here. We're in this mode where we are shipping things, something breaks, and we're constantly firefighting. How do we get a hold of this? Well, let's dissect what we were actually doing. We were in this mode, right? We were shipping code, we high-fived, we felt really great. There was a problem, we fixed that problem, we shipped new code, there was new problems, new solutions, new problems, new solutions. How many of us are in this mode? A lot of us. I appreciate the hand raises, thank you. Many of us are in this mode, and unfortunately, we fell into this trap as well. So because this talk is about mechanisms, this slide probably won't surprise anybody. So what we recognized was we needed a different way to solve the problems that were in front of us. And so let's talk about mechanisms. What the heck are mechanisms? The first point I wanted to share is a mechanism is not just a process. A mechanism is a systematic way to dissect the problem, identify the solution, develop metrics that can help us track the solutions that are actually in production, and delivering tools to enable our engineers to actually do what they do really well, which is shipping features and shipping value to our customers. So let's figure out how we solve this problem together. The first thing we spent time on is really understanding the problem. So you're probably sitting there and saying, but Zach, you already identified the problem. You had performance issues in production, right? Well, not quite. The problem that we had was we were shipping regression to production with every release, right? And that's a very, very different problem than having latency issues in production or customer feedback saying, hey, you broke something. So the problem that we identified after a little bit of digging was, you know what? Every time we ship something, there's a regression. So how many of you have heard, hey, our engineering teams need to do better. Our product managers need to do better. And when you hear that, when I hear that, that's an anti-pattern. That means there is something wrong with the way we are understanding this problem. So when we spent some time understanding what was actually going on, what we realized was it has nothing to do with our engineers shipping bad code. Engineers don't wake up and say, you know what? Today, I'm going to ship really bad code, right? I don't think I know an engineer that does that. I'm pretty sure most engineers wake up and say, hey, you know what? Today I'm going to wake up and I'm going to do something really, really amazing. But the problems persisted. So as we delved into this, we moved into the diagnosis phase. And what we recognized was as our teams were building these things, they were being asked to move really, really, really fast. And I'm almost certain every single person in the room can relate to this. We need to move faster. How often do you hear this statement from your CEOs, your CTOs, your VPs of engineering, and folks like me who will come into a team huddle and say, hey, we need to move faster. But the reality is, we're kind of brushing up against cap theorem here. You can move fast and ship poor things, or you can move with a little slower and ship high-quality things. So what this diagnosis helped us understand is our engineers didn't necessarily have the right tooling to actually ship great code. So what does that really mean? Our engineers were coding, they were shipping things into your pre-prod environments, testing their code in isolation. They would do a check mark because that's exactly what our sprint stories told our engineers to do. Write your code, test that locally, ship it to your pre-prod environment, make sure it works, check it into either your monolith or whatever architecture you have, and off it goes to production. What we recognized was our teams did not have the right tooling. Our engineers had almost no visibility into the code that they were shipping and the impact that it would have on downstream systems. And most importantly, our engineers did not have visibility into how their code was performing in production. So with that diagnosis, we delved into the solution. So what did we decide to do here? It wasn't just, hey, every time a customer request comes in, let's solve this and go back to our sprint. Our solution was we needed better alerts, better metrics, we needed auto rollback, we needed production monitoring. And with those, we knew that if there was a regression in our pre-production environment, we can fail the build. We knew that if we pushed code to production and our time to interactive or time to render latencies went up, we can auto roll back that code. How awesome is that? How awesome of an environment would that be, where you no longer have to rely on your customers, but you can rely on the systems that you have to tell you that you're breaking something or there's an experience that you have delivered that may be customer impacting. So that was our solution. But we didn't stop there. We moved into the tooling phase. So we recognized that this is what we needed to do. But our engineers still didn't have the right tooling. So what did we do? We went out and bought a whole bunch of new tools. We went out and built a whole bunch of new tools. These range from implementing things like logging with Splunk, Datadog, signal effects, having front-end telemetry in Sentry, having our front-end telemetry in systems like New Relic and Sumo Logic, having feature flagging systems, that, for example, Split.io or SigStat and so on. By the way, none of those folks are paying me. Those are just the systems that we're using. But the point of the story is, without the tooling, what we were relying on was good intentions. We expected our engineers to do the right things, but we weren't actually giving them the right tools to enable them to do their job really well. So as we delivered this tooling, we didn't just say, hey, now our engineers have the tools, let's move on. The next thing we did was we started tracking adoption of those tools. So is each team leveraging the new systems that we delivered? Is each team using StatSig? Is each team, ignore the platform names, is each team using the feature flagging systems we delivered? Does each team have the right dashboards? And so on and so forth. So now we have moved away from, here's a problem, let's go solve it. Here's a problem, let's go solve it, to really, really understanding what caused those problems, diagnosing the root cause of those problems, identifying the solutions, delivering tooling, driving adoption, and most importantly, inspecting. So let's talk about what the heck this means, because inspect might sound like a bit of a tough word at times, right? So what does inspecting mean? Well, let me give an example. So one of the rituals that we set up as part of this process was to have weekly operations reviews. And some of you are going, ugh, more meetings, right? Yes, more meetings. Here's what we did in our weekly operations reviews. All the engineers, all the managers, all the executives in the team came into a room and we collectively reviewed our dashboards. Why is that important? Sure, dashboard reviews are great, but here's what it revealed. Our dashboards were not actually reflecting the experience that our customers were getting. So as an example, our customers were saying, hey, this page is actually taking about 10 seconds to load. But what our metrics were showing was it was actually loading in about a second, not a minute. Somebody at Atlassian is going to be very angry that I said that. But our customers were saying, hey, it's taking 10 seconds to load, but our metrics were showing 1 second. That raised an alarm bell with me. So I started poking into that metric, only for us to discover that the monitoring daemon that we had sitting on our host were sampling, doing an average, and then emitting the metric. Now that was actually hiding the real experience that our customers were getting. What I really wanted to see was what was the P50, what was the P90, what was the P99. But when you are in that situation where you say, hey, I've built a dashboard and I've done a check mark, we would have left that problem unsolved. We would have still not been able to catch that. So as leaders, one of the most important things that we can do is continue to inspect the things that we think are solved and make sure that when we solve a problem, it remains solved. And that's why inspections are such an important part of this idea of mechanisms. So now we have moved away from, here's a problem, we're going to go firefight, solve it, to, hey, here's a problem, we're really going to understand what's causing that problem. And when we solve that problem, it remains solved. So as a quick summary, this is what we ended up doing. We added dashboards, we added alerts. We made sure that those dashboards really, really, really prevented regression. And when there was regression, there was alerts, and we can actually see that regression on the dashboard. We implemented tools and systems. We added launch readiness reviews. We added metrics deep dive sessions where new teams who are delivering code to production could actually use a set of senior engineers to stress test what they were delivering to production. We added auto rollback to our production pipelines, so when there was regression, that code was automatically rolled back. And that way, our customers were not the ones telling us that we had a problem. Our systems that we implemented told us that, hey, there is a problem, and I've automatically rolled back your code. And lastly, inspection, right? As leaders, it's our responsibility to constantly make sure we are inspecting the things that we think we have solved so they remain solved. So if you're like me, I'm a visual learner. So here's how our process evolved. Here's what we used to do. We would have a solution, we'd have a problem, we'd deliver a solution, and we were in that cycle constantly firefighting. What we evolved to was a far more systematic process where when a problem came in, we would spend that time diagnosing that problem, identifying the real root cause, so we were not solving the symptoms of the problem, rather, we were solving the real pain, right? We looked at the solutions, we delivered tooling that enabled engineers and product leaders, business owners, to actually implement those solutions. We looked at adoption, and then we finally implemented an inspection cycle. This isn't the answer to everything, because there are often anti-patterns if you're applying mechanisms incorrectly. Similar to how we talked about this idea of problem solution, not all mechanisms work. So here are some of the anti-patterns to look out for. If your dashboards and alerts don't actually tell you what the real customer experience is, or if your dashboards cannot tell you that this is the experience that we're delivering to your customers, that's an anti-pattern. If you are too focused on leveraging tools rather than measuring their effectiveness, that should be a warning flag. If you are rigid and unwilling to deprecate tooling, that's an anti-pattern. And finally, if folks aren't showing up to your inspection rituals, that's also a big problem. And what that can also mean is, hey, is this the right way to solve this problem? So mechanisms, when implemented well, they can solve the problem and make sure that those problems remain solved. When mechanisms used incorrectly, these are some of the anti-patterns to look out for. So in other words, this is my mantra: mechanisms over process, right? But many of you are sitting here saying, hey, Zach, you're sharing stories from Amazon, you're sharing stories from Atlassian. Can we actually apply this at a much, much smaller scale? The reality is, the answer is yes. And my experience tells me the way we have solved problems at AWS, we took those problems to a different scale at Atlassian, and I took those same systems, this idea of mechanisms, to a much, much smaller company like Linktree, where it really helped us systematically solve these problems and get out of this mode where we're constantly firefighting. Now, if there's one thing I would ask the audience to remember from the last 20 minutes that I've been up here talking, is this is one of our famous Amazon adages, and that is, good intentions don't work. Mechanisms do. What does this mean? It means we cannot rely on people to do the right things. We can often only rely on our systems to do the things we need it to do. So with that, I wanted to thank everybody for listening. Appreciate the time. And that was all about mechanisms. Thank you.
Can you design a mechanism to make the internet work so that people can ask questions?
Yes, but not in the time we have.
Unfortunately. Okay. Well, there's at least one in our Slido. I'm sure people have been logging questions and will continue to do so. I'll keep checking, but if not, we might have to resort to the microphone runner mechanism, okay? All right.
It's already working.
Are mechanisms applicable to both when something is breaking, like an incident, and also for other types of firefighting, bugs, prioritization, changes, etc.?
I think this is a really great question. So, the example that I used was really about, distractions coming in and helping us solve that particular problem. But the way that I use mechanisms is to systematically identify the root cause of a problem versus just constantly being in this mode where you have a problem and you're solutioning. We use mechanisms at Amazon, and I hope at Atlassian, and I hope at Linktree, where I've been able to leave some fingerprints constantly. So let's use this example of bugs and prioritizing changes and so on. What is a mechanism that you can possibly use for prioritizing changes? Well, if you're in a startup, your CEO is coming in and saying, hey, I want this feature. Your CPO may come in and say, hey, I want this feature. Well, how do you break that gap? How do you make sure that your engineering teams are not constantly distracted? One of the mechanisms that you can use is a weekly product review. I know it sounds really, really simple. But as those requests come in, systematically putting each one of those into a triage queue in Jira or whatever system that you're using, Asana or whatever's out there now, and leveraging that audience to help you prioritize, then that gets into next week's backlog. Now, of course, this sounds overly theoretical, but the reality is, if you are constantly taking in feature requests, your team is going to be in constant firefighting mode. So simply leveraging this as a process or as a mechanism can really help your team stay focused, deliver things, and deliver them really well.
Awesome. All right. Unfortunately, I have no more questions coming up, but I'm sure there are questions that people have raised in the Slido. Is anybody like to ask your question live? It's hard for me to see everyone. How about over here?
Yeah. What do you see this difference between mechanism and a process? I know you said mechanism better than process, but some of the things you talk about are very similar to processes that teams build. So what do you see as a difference between mechanism versus process?
Yeah, I think that's a really great question. So in a process, often what you have are steps. You do X, you do Y, you do Z, and you go on and on and on. The key difference that I believe is between a mechanism and a process is a mechanism allows you to spend that time diagnosing, really spend that time separating the root cause from the symptoms of that problem. And you can do that systematically across many, many, many different types of problems. So to summarize, a process often is it must be followed. It is, you have A, B, C, and D. Whereas with the mechanism, if you find that your tooling isn't working, you go back to diagnosing. You find that, the adoption is low, you go back to diagnosis. So in other words, mechanisms are more of an agile way to really dissect a problem rather than a process where it's more waterfall oriented. So I hope that answers your question.
Any other questions? Way back here?
What tools did you use to collect the metrics and create the dashboards?
We had in the example that I shared where we had performance regression constantly, the tools that we were using were mostly off-the-shelf observability tools like Datadog, Splunk, Sumo Logic, New Relic, Sentry, and so on. Those were basically off-the-shelf tooling that we used. I don't know if that answered the question or if that was just too direct of a response.
Did you do any regression testing or?
I think that's another great question. We ended up setting up a bunch of pre-production environments where we had, locally, we've made sure that the unit tests were running. We also made sure things like each pull request had 2 shipits, just as an example. It's a simple approach, but what that allows you to do is make sure that the code you're shipping has more eyes on it. It's not the only approach, but it helped in a very simplistic way. We use things like auto rollback that we plugged into our CI/CD systems. We used Bitbucket. So when we had regression in our Gamma environment, we would automatically roll those things back. So a variety of tools to systematically solve these problems. Regression testing was just one of those, one of the environments that we set up.
All right, thank you.
All right, I think we have time for a couple more questions right here.
Hi. So we spoke about all the tooling that you used in your mechanisms, but how do you build a mindset of mechanism as an engineering leader for across companies, big and small, in your experience?
Oh, I can answer this one. It's just fun to say, mechanism.
I wish.
Such an amazing question. The one thing we didn't talk about is a culture shift and how important it is to drive that culture shift. The most important thing that we can do as leaders is to role model. It is not going to be an easy change to get all of your engineering leaders showing up to your weekly operations reviews. There is no silver bullet here. It is hard work, it is campaigning, it is getting support from your leadership team. And one of the most important things that we can do as leaders is show up ourselves, is to show up and drive conversations forward. So while we talked about the systematic aspect, we didn't touch on the culture aspect, which I think is just as important to drive up this adoption of mechanisms throughout your organization. So I wish I had a silver bullet of an answer, but it is hard work and role modeling that is necessary to really help your organizations understand the value of mechanisms versus problem solution.
I think we have time for maybe 1 or 2 more questions.
One question.
Oh, back here. Okay.
So, by a great presentation here. So, quick question on how do you implement this mechanism in fast-moving agile releases, where we have only 2 weeks of sprints for development, and then you have QA, then you got regression. By the time you diagnose something, things are in production, and next release starts developing, right? So that's a process. So how do you implement the mechanism in that scenario?
Certainly. I'm going to give a non-answer in this case, and that's going to be intentional. One of the things that we have to do as engineering leaders is to understand the trade-offs. And if we are constantly in a cycle where we're shipping bugs to production, let's be honest, our sprints are going to get derailed anyways. So as leaders, if we're not following these systems and if we're not diagnosing these problems, if we're not paying attention to what we're shipping, we're working on good intentions where we ship and things will get derailed anyways. So to go back to this idea of, hey, we're in a fast-moving environment, well, the trade-off here is that what is going to slow you down in the future? If you continue to operate in a way where we are shipping bugs, we are shipping regressions of any sort to production, the piper has to get paid. And the reality is that catches up to you. So, we don't want to over-rotate as an organization. Instead, we want to slowly introduce good practices, and over time, they get embedded into our culture. So I recognize that was a non-answer, but I'll stick by it.
Okay, I think that is all we have time for, except for my special question, which is, what do you enjoy so much that it makes you just completely lose track of time?
All right, I've got two answers. One, I'll start with professionally, if I'm being it sounds a little cheesy, but doing this, sharing and paying it forward, sharing all the things that I've learned as a leader over my career, and passing it on to other leaders who are willing to listen. That's on the professional side. On the personal side, cycling is what I do on the weekends, and cooking. So if you're honking at somebody on the road, I'm sorry, that's probably me. So road cycling is where I spend a lot of time away from everything.
All right, amazing. Thank you so much. All right.